Okay, where was I? This glow. The universe was slightly hot, not much, but there was an afterglow. It's kind of like you'd expect after a bomb went off. There's some heat left over after the flash is gone. And we picked that up. Okay? But it fills the entire universe. There's no hot center. We can't find where the heat came from. So let's do a little mind experiment. A gradient is a change in value of a number compared to another. On a road, a high gradient is a steep hill. A zero gradient is a flat line. So if you were walking up the side of a mountain, it would be very obvious to you your altitude is changing. But if you started on, say, one of the deserts in Africa and you stepped out of the sea and you see flat sand stretching as far away and you walk for 100 kilometers and you only go up 100 meters in altitude, you won't perceive that slope. It's too gentle. Even if you wound up higher in altitude than a mountain in Newfoundland, it's not changing quick enough for you to observe. So let's imagine there are several explosions and they left a heat trace on the ground. So there's explosion A, B, and this big one, C. Which explosion could you find the center of it easier? Where could you find the hot spot left behind? Well, if you were object B, if you were right here, if you walk from A to B. If you walk from A to B, you would find you went from cool to warm in a certain distance, and you'd probably pick it up. If you walked from A to B to this heat source, you would suddenly find the ground getting really hot really fast. You could rub your hand back and forth on the ground here and find the center of heat. But what if the explosion was this big? Walking from here to here on that big circle, would you detect any change in heat? No. The gradient is too shallow. So the easiest way for you to find the center of a hot spot would be if I just put like a pinpoint sized heat source on the ground. You could rub your hand over the desk and find exactly where that hot spot is. It would also be much easier to find the hot spot left behind by a coffee cup than the hot spot left on a desk because I had a heat lamp 3 meters above the desk on a slight angle. It wouldn't be sufficient for you to find. So we've mapped the heat of the universe. And this is the entire sky twisted into this shape. It represents horizon to horizon, north to south. These are the heat plots. The difference between the blue and the red dots is less than 3 degrees Kelvin. Kelvin is the same as Celsius. So there's less than a 3D temperature difference. Do you see an obvious gradient in temperature? Do you see a center forming where there seems to be a hot spot? No, you don't. The universe is completely lukewarm in all directions. So would that be evidence of a tiny, a large, or an absolutely immense explosion if we see no change in temperature? The answer is whatever blew up the universe is mind-bogglingly big. We don't see a temperature difference anywhere. So if someone says, I want to find the center of the universe, good luck. It's so big, we're like a bacteria trying to find the center of the heat spot you left behind on a chair. You're just too small to see it. So there does not seem to be a center of the universe. Is the universe infinite then? And that's what we'll do next. How big is the universe now? And can we get any idea of where the center actually once was?